It began with a silence so complete that it felt unnatural. When 3I-ATLAS slipped behind the sun, astronomers expected chaos when it returned. They expected heat, gas, dust, the familiar cometary transformation every object undergoes during perihelion. But when it emerged again, the universe refused to follow the script. Instead of a blazing tail, instead of fragments or a plume, astronomers saw something that made entire observatories fall quiet. A sphere of light, compact, stable, perfectly intact, no tail, no debris, not even a hint of vapor. It drifted out of the sun's glare like a ghost that had walked through fire without being touched. Comets don't survive perihelion like that. They flare, they shed, and they leave trails stretching millions of kilometers behind them. But 3I-ATLAS didn't burn at all. It brightened, yes, 5 times brighter in a matter of hours, but it did so without losing mass, without tearing itself apart, without behaving like ice under solar heat. It simply glowed. Its light wasn't red or white or dusty like every comet ever studied. It had turned blue, bluer than the sun itself, a color that shouldn't exist in cometary physics. Blue means heat, reflection, metal, energy, not evaporating ice, not frozen dust. And as the images sharpened, the glow did something even stranger. It stayed steady. Dr. Avi Loeb called it an anomaly that refuses to explain itself, and for once, even that sounded too cautious. Because when astronomers checked the instruments that should have detected sublimation, they found nothing. No water vapor, no gas jets, no plume, nothing that could account for the sudden brightness increase. For 3I-ATLAS to glow that intensely without shedding mass meant something else was forcing the light outward, reflecting or emitting it with precision. If it were outgassing, it would have lost billions of tons of material, but the region around it was pristine, cleaner than any active comet ever observed. Not a single particle drifted from its surface. Then the comparison images arrived, and they changed everything. The same telescope that had imaged Comet Lemon under identical conditions turned toward 3I-ATLAS. Lemon showed the classic sweeping tail, carved by solar wind into a luminous arc. 3I-ATLAS showed none of it. Not a streak, not a trace. Just a round, stubborn sphere glowing as if the sun's radiation simply passed around it. The contrast was painful. One obeyed the laws of physics, the other didn't. The simplest explanation, the one no scientist wanted to say out loud, was that maybe this thing wasn't a comet at all, and then the orbital data arrived, making silence swallow every room a second time. 3I-ATLAS was not following the gravitational curve predicted by Newton's equations. There was a tiny shift, just enough to measure but too smooth to ignore. A gentle, continuous acceleration, not violent or chaotic, but steady, as if something was guiding the object with invisible hands. If it were normal outgassing, the object would flare irregularly, tumbling as jets erupted from its surface. But 3I-ATLAS didn't tumble. It didn't wobble. It moved cleanly, precisely, untouched by randomness. Loeb's estimate was shocking. For this acceleration to come from outgassing, the comet would need to lose at least 1/10 of its mass in hours. The sky should have been filled with a glowing cloud of debris, but space around it was empty, clean, undisturbed. Spectral readings added another layer to the mystery. The object was shedding nickel in quantities far greater than iron, a ratio no natural comet exhibits. In nature, nickel and iron appear together, fused in cosmic dust balanced over billions of years, but this object displayed a signature similar to industrial alloys, materials engineered to survive extreme heat and stress. And then came the polarization data. When light bounces off dust and ice, it twists predictably, but the light from 3I-ATLAS twisted erratically, almost unnaturally, as though its surface wasn't rough like rock or porous like ice, but designed to manipulate reflection. Within weeks, Loeb had listed nearly 10 separate anomalies: the blue glow, the acceleration, the nickel-rich signature, the absence of a tail, the object's perfect survival through 770 watts of solar radiation per square meter at a distance of 203 million kilometers, the alignment with the planetary plane. the trajectory threading that passed close to Mars, Venus, and Jupiter without deviation, even its proximity to the historical WOW signal coordinate. Each detail alone was odd. Together, they formed something bordering on impossible. Scientists tried to dismiss the idea of intent, but orbital mechanics refused to cooperate. Interstellar objects rarely travel in the ecliptic plane, the flat sheet where planets orbit. Yet 3I-ATLAS moved through it with uncanny precision. Its path threaded the solar system as though using planets for subtle adjustments. When plotted backward, its trajectory appeared to have been engineered to slip behind the sun at the exact moment Earth would be too far out of alignment to observe it. The chance of this geometry happening randomly is roughly 0.005%. Randomness doesn't hide that effectively. And then came the moment few expected. Avi Loeb was asked to brief members of Congress. He explained the anomalies carefully, reminding them that science follows data, not comfort. He told them the simplest explanation might still be natural, an exotic rock formed in an environment we don't understand. But he also acknowledged that if the data continued to hold, then something far more unusual could be at play. One lawmaker asked whether any rocket on Earth could intercept it. Loeb had to answer no. 3I-ATLAS was traveling 3 times faster than our fastest spacecraft and was nearly 50 times larger than SpaceX's Starship. Even if humanity wanted to catch it, we couldn't. It was beyond our reach. All we could do was watch. And still the object drifted on, silent and unchanged. No tail, no shedding, no breakdown. It sailed through the solar wind like a sphere immune to radiation, glowing steadily as if physics applied only to everything else. The closer it came, the more it seemed like a visitor observing from behind a glass wall, its purpose hidden, its presence undeniable. Telescopes watched. The data poured in. Nothing made sense. But this was only the beginning. In the days that followed its mysterious brightening, 3I-ATLAS refused to behave like anything recorded in astronomical history. The deeper scientists looked, the stranger it became. Orbital analysts expected the acceleration anomaly to fade as the object drifted away from the sun's heat. Instead, the opposite happened. The deviation continued, smooth and unwavering, as if the object were responding to an instruction rather than a natural force. Even seasoned dynamicists found themselves rerunning equations, wondering if they had input errors, but the math was correct. It was the object that wasn't. Every known comet reacts violently during and after perihelion. Outgassing shifts their rotation, cracks their surface, and scatters dust into space. Yet 3I-ATLAS remained perfectly intact. No fragmentation, no jets, no rotation changes. Its spin stayed slow, steady, and strangely suited to structural stability, as if designed that way. If it had shed the mass required to cause the observed acceleration, it should have been breaking apart, tumbling uncontrollably, disintegrating into a cloud of debris thousands of kilometers wide. Instead, it drifted forward like a ship catching a wind no one else could feel. Chemical analyses offered no comfort. The spectral lines pointed to an abundance of nickel, far more nickel than iron, a ratio so unnatural for comets that chemists dismissed the first readings as calibration errors, but the results repeated across multiple observatories. Whatever was on the surface, it did not resemble natural cosmic dust. Nickel-heavy surfaces are found in engineered metals, in alloys designed to withstand corrosion and thermal stress. To see such a signature on an interstellar object was like finding fingerprints on a meteorite. The more it was studied, the more artificial it looked. Then the polarization data arrived. When sunlight reflects off ice or rock, the polarization is predictable. But the readings from 3I-ATLAS veered dramatically outside the expected spectrum. The light twisting off its surface was chaotic, extreme, more like the reflection from a structured or layered material rather than an irregular natural body. Some scientists wondered if its surface was smoother than it appeared or coated with something designed to diffuse harsh radiation. Others quietly suggested it might be reacting to light itself, modifying its appearance to hide its true nature. None of the explanations were comforting. Around this time, Loeb's list of anomalies grew to nearly 10. the blue color. The nickel signature, the perfect survival. The missing tail, the unexplained acceleration, the plane-aligned trajectory. The sun-concealed perihelion timing. Each detail added another piece to a puzzle that refused to resemble anything natural. And as media attention exploded, NASA and ESA were forced to comment, though in cautious, carefully constructed sentences. No one wanted to spark panic, no one wanted to repeat the debates around Oumuamua, but the silence from official agencies did little to calm anyone. If anything, it made the public even more curious. What disturbed astronomers even more was the object's path through the solar plane. Interstellar visitors tend to slice through the system at odd angles, like needles passing through fabric. Their trajectories are random, unbound, unpredictable. But 3I-ATLAS moved almost exactly along the ecliptic, the thin plane where all major planets orbit. It wasn't just passing through, it was traveling with us, threading its course between Mars, Venus, and Jupiter with unnerving accuracy. Even stranger, the timing of those passes hinted at potential gravitational assists, as if the object were using planetary gravity wells to adjust its path. Nothing in nature chooses efficiency, but navigation does. When researchers traced its trajectory backward, the alignment became even more unsettling. It had arrived at a moment when Earth would be on the opposite side of the Sun during perihelion. The one time our telescopes couldn't record its most critical phase. A coincidence? Maybe. But the probability of such perfect timing was barely 0.5%. Random objects don't coordinate themselves around the observational limitations of a single planet. As public interest grew, congressional staff reached out to Harvard, and soon Avi Loeb found himself briefing elected officials behind closed doors. He explained the anomalies without exaggeration, showing them the infrared data, the orbital deviations, the brightness curves, the spectral ratios. He reminded them that science is not about belief. It is about evidence. Galileo faced the same resistance, he said, when he proved Earth was not the center of the universe. The truth remains the truth, even if no one accepts it at first. One senator asked the question everyone feared. Could we intercept it? Could we send a probe? Track it up close? Loeb answered honestly, no. At its current velocity, 3I/ATLAS was traveling nearly 3 times faster than our fastest spacecraft. Even the most advanced launch systems on Earth could not hope to match it. By the time engineers even designed a mission, the object would already be far past our reach. It was like watching a distant ship glide across the horizon, knowing we could never catch it. The room fell quiet, because there is a kind of fear that comes not from danger, but from helplessness. When something enters your solar system, behaves in ways no natural object should, ignores the sun, ignores heat, ignores physics, accelerates smoothly without shedding mass, follows a path with unsettling precision, and yet remains completely unreachable. The only thing humanity can do is observe and wait. Outside government halls, astronomers continued their analysis. Some argued passionately that the object must be natural, that unknown cosmic processes could account for every anomaly. But even they admitted that if it were natural, then the universe was far stranger than previously imagined. A rock forged in an environment no telescope had ever glimpsed, a relic shaped by ancient chemistry, a survivor of conditions so extreme that its behavior simply didn't conform to our physics. Others considered the opposite possibility, that 3I/ATLAS wasn't just unusual, it was deliberate. Not a probe sent to Earth, not a weapon, something quieter, something older, perhaps a relic of a long-dead civilization, a vessel hardened against time, still carrying traces of its creators, perhaps a fragment of technology that continued to function long after its purpose had been forgotten. As December 19th approached, its closest approach to Earth, the tension deepened. No one knew what the object would do. Would it change course? Would it glow again? Would it remain the same stubborn sphere of light sliding through space without a tail, without a trail, without explanation? The only certainty was this: nothing about 3I/ATLAS was behaving as it should. And with each passing day, astronomers felt they were witnessing something unprecedented, something that violated the quiet expectations humanity had about the cosmos, something that refused to be ordinary. and deep in the cold space between the planets, 3I-ATLAS kept moving, silent and unbothered, carrying its secrets a little closer to us with every hour. As December approached and telescopes worldwide sharpened their gaze, 3I-ATLAS drifted closer with the same eerie, tailless calm it had shown since emerging from behind the sun. No flare, no shedding, just a quiet sphere of blue-white light cutting through the solar wind as if physics were merely a suggestion. Scientists waited for the slightest change, any sign that its behavior might finally align with natural cometary models, but the object remained indifferent to every expectation placed upon it. Its glow stayed steady. Its surface remained untouched. It moved with a confidence that felt almost intentional. More observatories joined the effort. The Galileo Project's newest installation in Las Vegas captured long-exposure images that only deepened the mystery. Ordinary comets fan out in soft arcs of dust. Their brightness flickers as they rotate. Their tails stretch like ribbons in the solar wind. But 3I-ATLAS remained a perfect sphere on every exposure, a defiant blur of concentrated light refusing to reveal any structure beneath its surface. In scientific meetings, the question shifted from "what is it doing" to "what is it hiding?" Radio observatories attempted to detect signals or emissions, hoping for even the faintest spectral irregularity, but the object remained quiet. Too quiet. For something moving this fast, this close, and this brightly, the silence around it felt unnatural. Natural objects are messy. They fracture. They crumble. They roar with energy as sunlight tears their surfaces apart, but this one glided through that fury with serenity, almost with purpose, as though built to withstand stresses ordinary rocks would never survive. Inside the Pentagon's newly formed All-Domain Anomaly Resolution Office, analysts reviewed the data repeatedly. Official statements insisted there was no evidence of extraterrestrial influence, but privately, several officials admitted that nothing about this object resembled the expected behavior of a comet. It was too stable, too resilient, too controlled, and perhaps most unsettling of all, too quiet. A visitor that moves through the solar system without speaking raises more questions than one that sends signals openly. Scientists who argued for natural explanations tried to remain grounded. Maybe this was simply the first object of its kind humanity had ever seen, a type of interstellar body forged under conditions our solar system never produced, a relic from a star system with drastically different chemistry, a survivor of events so extreme that its composition and behavior had no parallel here. That explanation, while comforting, created its own kind of unease. If nature could build something like this, then our understanding of cosmic formation was incomplete, not slightly, but profoundly. But there was another interpretation, the one no one wanted to say too loudly, the one Loeb hinted at only cautiously. If this object behaved with precision because it was built with precision, then humanity wasn't watching a comet. It was watching technology, not active technology. There were no clear signs of propulsion or transmission, but ancient technology, hardened by time, altered by radiation, still intact enough to cross star systems without disintegrating. If so, then 3I-ATLAS might not have been sent here. It might simply be passing through, following a trajectory older than our civilization, a silent survivor of something that once was. As the date of closest approach neared, astronomers prepared for the possibility that the object might reveal something new. But when the day arrived, the universe chose silence again. 3I-ATLAS drifted past Earth's orbit at a distance that was safe but close enough for high-resolution imaging. Instead of clarity, the new images offered only more questions. The sphere remained smooth. No thrusters, no fractures, no surface activity, not even a glint that hinted at panels, joints, or geometry. Yet its behavior still contradicted the physics of comets. It neither slowed nor flared. It simply moved onward as if following a path written long before humans learned to track the sky. Astronomers compared every centimeter of data from before and after perihelion. They traced its motion across millions of kilometers. The acceleration anomaly persisted, not erratic or explosive, but delicately sustained, like a steady push from a force that left no trace. If it were natural, It was the most efficient natural propulsion ever recorded. If it were not natural, it was a reminder that our instruments are catching only the faintest shadow of what it truly is. Loeb, in his final public statement on the phenomenon, said something that lingered with every scientist who heard it. He explained that ignoring data doesn't make it disappear. The universe does not wait for human comfort. It simply exists as it is. Just as it took centuries for humanity to accept that Earth was not the center of the cosmos, it might take decades to understand objects like 3I-ATLAS. Its refusal to behave like a comet is not a theory. It is an observation. And observations, no matter how inconvenient, demand explanation. Now, as 3I/ATLAS drifts farther from the sun and deeper into the cold, its glow remains unbroken. Its speed remains high. Its silence remains absolute. The object doesn't seem interested in Earth or any planet. It does not scan, signal, or approach. It simply exists, transiting the solar system with an indifference that feels almost ancient. Whether natural or engineered, it acts like something built to endure, not to communicate. Some astronomers say that if it slips back into the void without revealing answers, humanity will be left with nothing but data and speculation. Others believe this is the beginning of a new chapter in astronomy, one where interstellar visitors become more common, and anomalies like this are clues to a larger cosmic pattern we haven't yet uncovered. A few whisper that perhaps this is not the first of its kind, only the first we were advanced enough to notice. If that's true, then the universe may be far more alive and active than we imagined. And still, despite the fear, the mystery, and the unanswered questions, one truth remains. For the first time in generations, the entire world looked up together. For a moment, humanity set aside borders, beliefs, and politics, united not by fear or conflict, but by curiosity, by a shared sense of awe, by the realization that the cosmos is still full of wonders that defy our expectations. Maybe 3I/ATLAS came to teach us nothing more than that, to remind us that discovery is never comfortable, that the universe does not owe us answers. It only offers questions. It challenges us to keep watching, to keep searching, to accept that the unknown still thrives in the space between stars. And when this object finally fades into the darkness beyond our reach, humanity will remember the moment a tailless sphere of light crossed our sky and made us wonder whether we were witnessing nature at its strangest, or something quietly watching us back.